Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Dogba Jr., your math tutor. In my today's lesson, I will be looking at differential equations, and particularly I'll be looking at variable separable method. So in the previous lessons, we did variable separable, but we did the case where the variables can easily be separated. What if the variables cannot easily be separated at the first look of the problem? So then it means that you have to bring in the second type or the second case or whatever it may be that we call reducible to variable separable. So yeah, some of the problems might not easily be variable separable problems, but you can reduce it to variable separable problems and find a general solution. So let's solve this problem. We have question 29, x plus y plus 1 dy by dx equals to 1. So what we need to do is that we can substitute what is within here with some other variable. So we can call that, for instance, we call that t. T equals to x plus y plus 1. Now, the essence of doing this is to eliminate the variable x. So if x is differentiated, you just get 1. So you'll be left with two other variables now, but those two variables are like the functions. They are like separate functions, but those functions are in the variable x. So that's the main reason. So even if you have like x plus y raised to the 7th power, the key is to eliminate this x. If you have 4x plus y plus 3, the key is to eliminate this x. Okay. So now we differentiate both sides. Remember that t is the name of a function and y is also a name of a function. So if we differentiate t, which gives us 1, we attach the t by the variable within the in t, which is x, equals the derivative of x is just 1 plus the derivative of y is 1 also, but since y is a function, so we say dy by dx, the derivative of 1 goes to 0. Now we have eliminated x. The next thing we need to do is to solve for this dy by dx. So this dy by dx, we can solve by transferring 1 on the other side of the equation. So this is just dy by dx. So this is our dy by dx. Now let's put it in. You have x plus y plus 1 dy by dx or equals to 1. So now what is this? This is just t, and then this dy by dx, which is this one now, it is dt all over dx minus 1 equals to 1. So we can multiply this entire thing by dx to get rid of this x. So this will lead us to dx times this first numerator. It just gives us t dt. So this x and dx will go out. So the x times 1 also, but remember t times this minus 1. So it gives us minus t dx. And then dx times 1 is just equal to dx. So we have t dt. Now we want to make all of the t expressions on one side of the equation, and all of the x expressions on one side of the equation, thereby making t to be the subject of the equation, because t is almost like a kind of, it's like the function. So the name of the function. So we can prefer making t the subject of the equation. We can decide to make x the subject, whatever the case might be. It doesn't matter. But I just want to traditionally be making my function to be the subject of the equation. So as transfer this, I have t dx plus dx. So what I can do is t dt, I can factor out. So I will have dx. Now what is left here is just t. So dx into the dx is just 1. Now, but this is x. So I don't need t attached to this x. I need all x. So I have to divide both sides. Divide this side as well. So this and this will go out. So I'm left with t dt all over t plus 1 equals to dx. Now I've separated the variables so I can integrate both sides. Now for this side, I can apply some other trick. Now since I have t plus 1, I can say t plus 1, then I subtract 1 from it. So even if you have t plus 2, you could say t plus 2 minus 2, just like that. So now, considering that this is a kind of linear factor, so divided by t plus 1, the t, and then the integral of the x is just equal to x. So I can separate, so I will have t plus 1 all over t plus 1, the first two terms, because these can go out, dt, minus the integral of 1 all over t plus 1, dt equals to x. So this is just 1. So the integral of x of the t will just give us t, and then minus, this is the integral of 1 all over t plus 1, which will give us the ln now because this is a linear factor, all equals to x. So this is ln of t plus 1 equals to x, plus some arbitrary constant c. So, but what was c? C for the onset, oh, that's a t. T was x plus y plus 1. So where we see t, we should put x plus y plus 1. ln of t is x plus y plus 1, right? And then this 1, remember, equals to x plus c. So we have this x cancel this x. So I'm left with now y plus 1. Now I can even send this ln on the other side of the equation, doesn't matter. This will just be positive ln of x plus y plus 2. And then this is now equals to c. If this 1 goes across, now it becomes minus 1. But c minus 1, a constant minus a constant, it ends up in a constant. So we can just represent this whole thing by a constant. We can call it a, whatever constant we want to represent that by. So I just call that capital A. So y equals to the ln of x plus y plus 2. This is not equal. This is what is it? This is plus some e. So this is our general solution of the differential equation. So thanks so much for watching. See you in our next lecture. Thank you.